This is Alfred Wegener. Very German. He might have been Austrian. Anyway, lived from 1880 to 1930. Now, this poor bloke, he came up with a really great idea and then died tragically. I think he was frozen in the Arctic Circle without actually realizing. Well, he knew he was right. He knew it made sense. He knew that he had the evidence for it. But it's kind of laughed at by the scientific community, and that sucks. It doesn't really happen like that anymore when people make groundbreaking discoveries, but certainly when, 100 to 200 years ago, sometimes people were quite resistant to change, particularly if it didn't suit ideological beliefs, like, I suppose, like religion. So, Earth's surface is changing. So is this a jigsaw puzzle? Can you make this fit together? Now, any primary school student can say, we can move North America and South America into Africa, and it fits quite nicely. The other stuff isn't so easy to look at. This relies on things rotating and also Antarctica down here. But we can see in the North and South Atlantic, absolutely. It's not a coincidence. So Alfred Wegener hypothesized this. I'm sure he wasn't the first to notice it, but he was the first one to put it together. And by putting the jigsaw puzzle back together, he could see that the fossil record matched up. Now, his idea was that the continents drifted or floated about the surface of Earth. That wasn't quite right. It was a good idea, but he couldn't come up with a driver for it, and so he thought that they'd sort of drifted. Yep, put that video in the link. So we've got a record of continental movement that goes back at least 750 million years. So we can reconstruct the way that the Earth's surface moved around for the last 750 million years, which is pretty cool. So Wegener's evidence for continental drift. So the jigsaw idea that plates fit together nicely. And when you fit the places together, when you fit the plates together or the continents together, they geologically fit really nicely. So your mountain ranges lined up, your rock strata lined up, so same rock types. Wasn't a coincidence. They lined up brilliantly. Fossils were a big player. So we had in the tropical regions, we had these glacial striations. Now, how glacier is going to be in the tropics? So there is one idea, snowball Earth. Yep, of course, at some stage, but not in the recent history. At the high latitudes, however, we found fossils from tropical plants. And we can see, so we got areas of geological fit here. We can look at that one. Certainly these two, like, how could that have happened any other way? There's just not that much of a coincidence going on. The simplest explanation is often the best. And we can see nicely here as well. So glacial deposits. So these are the directions of the striations. So moving away from Antarctica by the look of it. So here's our fossil distribution. Beautifully lines up. This helped us a lot to do with working out where Antarctica and Australia and India fit into the deal. So North America's over here. This is Glossopteris. And it was one of the most significant. So it's the green one. Look at that, goes through all of them beautifully. We can see that the climate or the conditions through there were ones that suited this particular plant. And it's not just that. If it was only one, it's a good indicator, but we can't call it irrefutable evidence. But when we've got this many different fossil types. And the other issue is when it's a terrestrial animal, land reptiles can only have migrated from Africa to South America if they were joined. They can't swim over. There were no boats or planes or anything like that. We're talking hundreds of millions of years ago. So or there was no ocean, but that's ridiculous. So they can't have walked. So that the only way they can get in those two different places are if they were once joined. Yep. I'll put the link to that video in the description so we can see Pangaea broke up. so 225 million years ago. So it happened over a long time. I'm sure you can find a video of that happening. That's really what this is. The scientific data showing how it formed and broke up. So what does Australia really look like? So the blue line shows at sea level. And we can see that all the way around Australia. Everyone's familiar with that shape. Now, if sea level changes, the shape of Australia changes. Like if it goes down 100 metres, for instance, all of this continental crust will be exposed. And essentially Australia will be attached to New Guinea, because essentially it is. Sea level is the only thing that that keeps the countries apart. Now, this is called the continental shelf. And funnily enough, it's not a coincidence, the continental shelf is where continental crust stops and oceanic crust begins. And we can see there's a fair bit up here in North Queensland, but then there's also all the way through here. The story of how that got there is pretty interesting. And we see this little country here, New Zealand. So, continent of Zealandia. It's not making that up. Mostly underwater. We've got a little bit at the surface here. So again, New Zealand should be considered a continent simply because of the continental crust that is around it under the ocean. And again, it's really just sea level that keeps that submerged. So evidence for plate tectonics is the age of the sea floor. So we can see the red colours are the youngest and the blue colours are the oldest. You will notice, and you should have identified, that generally the middle of oceans is youngest, and generally the edges are oldest. Something's going on here that's quite unusual. We'll get to that when we look at the San Andreas Fault, but we can still see that kind of in the middle. So what was over here has now disappeared under North and South America. Pretty interesting. And we can see that some of the oldest parts are right on the edge. Probably wouldn't surprise anybody if I told you that the Marianas Trench is over there, which is the deepest place on Earth. So the oldest oceanic crust generally is also the deepest oceanic crust. So oceanic crust is between 0 and 200 million years old. So the youngest is 0, right at this crack along here, and the oldest about 200 million years. However, the oldest remaining minerals from continental crust are 4.4 billion years old. Now that's a massive difference. So it's unusual. Well, once continental crust is formed, it remains unless it weathers and erodes. Whereas something's happening with the oceanic crust, to only get to 200 million years old, it means that oceanic crust has been around longer than 200 million years, but it means that the oceanic crust older than 200 million years has disappeared. It's gone somewhere. Some of you may have a pretty good idea of where it's gone. Another aspect is magnetic reversal. So we can see at these, they're called mid-ocean ridges. They're cracks. And they're caused by the crust, the oceanic crust being pulled apart. Now, the dynamo in Earth's core that's creating its magnetic field flips about every 450,000 years, so every 500,000 years on average. And now we know that because we can look at the rocks on the ocean floor. As we know, iron is a magnetic element, and minerals that have iron in them are magnetic, like magnetite, funnily enough. Interesting name. And what happens when this magma comes out at the mid-ocean ridge is that it's not set in stone, is it? It's not solidified in a solidified rock. It ends up becoming basalt. Now within the basalt, the magnetic minerals, or the iron that's in there, lines up with Earth's magnetic field, just like a magnet does. And what we've noticed is periodically over time, the direction has changed. So instead of all facing north, they all face south. When it flips, when it does flip, it means Antarctica will be to the magnetic north. And your little magnet that has a little red bit pointing that tells you where north is will actually be pointing the opposite direction. So where your magnet points will flip. Considering it only flips every 500,000 years, the fact that it does the complete flip in 100 years is pretty interesting. We're due-ish for one. Every year it slightly moves magnetic north, so you have to use your compass if you're doing orienteering or walking around the bush with a compass. Not that that really happens anymore. But you've got to look at where true north is, because your compass isn't going to point perfectly at north. It points to where magnetic north is, which is actually a little bit off.